A question has haunted our minds as to whether those worlds are suitable for human life. Scientists have discovered thousands of planets beyond the boundaries of the solar system, but most of them are completely different from the Earth. However, among the countless diverse celestial bodies spread across the endless space of the universe, there are some planets with parameters similar to our planet. They are warmed by the rays from the nearest star and have the abundance of liquid water on the surface. What is even more amazing is the fact that for many years, one of such worlds has been lurking very close to us before embarking on a space journey beyond the boundaries of the solar system. We have to decide how to select the most Earth-like planet from thousands of candidates. What parameters should this fascinating world have, and what should we consider first? Obviously, planets favorable to the formation and maintenance of life always attract considerable interest of scientists, however, selecting suitable celestial bodies. Among the many planets discovered so far, it is not easy to have clear selection criteria. Scientists have come up with the Earth Similarity Index, abbreviated. This index is based on a number of key parameters: radius density and average surface temperature of the planet. This combination allows calculating the mass of the object, preliminary estimate of chemical composition, gravity level, presence of atmosphere, and analysis of summit's characteristics. It also helps to determine whether there is liquid water on the surface of the planet and other information. The standard of this index is the Earth, with parameters considered ideal and E equal to 1. Based on the Earth Gravity Index, all the objects that we know are divided into 3 categories. The first category is objects with ASI below 0.5. These are mainly gas giant planets and objects that are extremely hot or conversely extremely cold. This is the category to which most of the planets and satellites in the solar system belong. Just one characteristic, exceeding the maximum value allowed for a celestial body, will become unfavorable for the formation and maintenance of life. For example, take Venus. The radius and mass of this celestial body is very close to the Earth. However, due to its close distance to the Sun and dense atmosphere, its surface temperature is extremely high. That is why, although the appearance is very similar to the Earth, the ASI index of Venus is not high, only reaching 0.4. Of course, having any life on its surface is completely impossible. Celestial bodies with ASI in the range 0.5 to 0.7 belong to the second category. These objects are significantly more similar to our planet. They are mostly rocky planets with relatively temperate temperatures, but can also be ocean planets, and even some large satellites. Interestingly, a high Earth Similarity Index does not guarantee favorable conditions for life. For example, low-mass planets cannot retain a thick enough atmosphere, while their magnetic fields are too weak to protect the surface from the deadly radiation. Other celestial bodies have. They are located too close to their host star and are tidally locked. Of course, all these factors greatly reduce the chances of forming and sustaining life. For the third category, it includes celestial bodies with high ASI, that is above 0.7. All these planets are located outside the solar system. According to estimates, the size of these worlds and the conditions on their surface are likely to be close to Earth. Among these planets, there is one planet that is most similar to ours, and it is only 12.5 light-years away from Earth. This amazing world orbits T Garden Star, a small red dwarf discovered in 2003. This star is 1370 times fainter than the Sun. This means it cannot be observed with the naked eye, even though it is quite close to Earth. The mass of this tiny star is about 9 pH that of the Sun, and its radius is about 5% larger than the Sun. The gravitational force is only strong enough to sustain thermonuclear reactions in the heart of the star. That is why the surface temperature is only 2900 Kelvin, which is about 2630 degrees C. Like all red dwarfs, the habitable zone of the Teegarden star is similar narrow, and very close to it in 2019, 2 exoplanets were discovered in its system after continuous observation of the star's proper motion. Interestingly, one of them is outside the star's habitable zone, and the other is inside the zone. The outermost planet is named Teegarden C, which follows a nearly perfect circular orbit around the center of the system with an orbital radius of 0.045 astronomical units. It completes one orbit every 11.5 days. It is likely a rocky body with a mass 11% larger than the star. With the Earth, its radius is estimated to be about 3.5% larger than our planet. Unfortunately, conditions on the surface of Garden C are not friendly. Due to the low brightness of its host star, this object receives 63% less energy than the Earth receives from the Sun. As a result, the surface temperature of the planet is estimated to average 47 degrees Celsius, too low to sustain life, at least in the forms we know of. However, there is a good chance that vast hidden saltwater oceans exist under a thick layer of ice on Teegarden C, like the satellites of Jupiter, for the planet located inside it is named Teegarden B. Actually, this planet is the most Earth-like object of all the planets discovered so far. Its ASI index is 0.95, just 0.05 less than the standard ideal value of Earth. This celestial body is located 0.025 astronomical units from its host star and takes about 5 days to complete a full orbit around it by following a nearly circular orbit. This exoplanet is constantly in the habitable zone of the star and receives 15% more radiation from the star than the Earth receives from the Sun. According to some estimates, the mass of Teegarden B is only 5% larger than our planet in radius. It differs from Earth by a very small percentage. This means the gravity value is also quite close to what we are used to on our planet. This makes us assume that the internal structure of this exoplanet is very likely similar to Earth, having a large metallic core covered by a thick mantle and an outer crust made of hard rock. Mathematical models show that Teegarden B's average temperature is 28 degrees Celsius, which is 14 degrees higher than Earth. This means that conditions on its surface allow the planet to retain liquid water, and its temperature profile is likely favorable for most microorganisms. Although Teegarden B is quite large and likely retains a relatively thick atmosphere, the radial velocity method used to detect exoplanets is still not enough to gather any information about the composition of the atmosphere. But it should be noted that the temperature profile of a planet depends directly on its atmospheric composition. For example, a thick atmosphere with a high proportion of methane and carbon dioxide will cause a strong greenhouse effect, while dense clouds of water vapor will reflect the sun's rays, reducing the temperature. We should also remember that however bright the parameters of this fascinating celestial body may seem, it is not completely perfect due to its proximity to its host star. It seems that the Teegarden flies always facing one side towards it, causing a large temperature difference between the day side and the night side. As mentioned, the Teegarden star is a red dwarf, and this type of star is prone to sudden flares. The amplitude of the fluctuations in its brightness can reach 30 ph. This has a big effect on the planets located nearby. However, the chances of Teegarden B being able to sustain life are high. Living organisms often show amazing survival abilities, and their adaptability cannot fail to surprise. For example, the ocean can act as a protection against deadly radiation, and the strong temperature fluctuations. Its top layer is capable of absorbing cosmic radiation, while its seepage can smooth out the temperature gradients. As we know, over time, primitive organisms could have evolved in warm waters, rich in energy and trace elements. Just a small chance is sometimes enough for life to develop into something more evolved. Every year, astronomers announce the discovery of dozens of new exoplanets. Number of new worlds discovered in the past 20 years. Hundreds of times more than the entire history of observation. Thanks to technological advances, scientists are constantly acquiring new tools to expand our knowledge. And one cannot help but feel that very soon the expected signs of extraterrestrial life will be discovered in some corner of the universe. Today's video on the Science Knowledge channel ends here.